For exercise 2.1.4, we need to recognise that there may be a couple of different types of factorisation rules that we need to use. So for this first one here, I'm going to start by taking the 2 out because I can see that 2 is a common factor of both 2x squared and 18. So I get 2 outside of x squared minus 9. You might think you're done there, but if you look really carefully at that, you should be able to see that's a difference of 2 squares. So I can further factorise that. So the 2 stays at the front. X squared minus 9 factors into x plus 3 times x minus 3. So that's that expression fully factorised. For number 2, I'll start by taking the 3 outside the brackets, and then I need to have a look to see if it can be further factorised. So taking that 3 out gives me a p squared minus p minus 12 inside the brackets. Now to see if this bit that's in the brackets can be factorised, I need to decide whether there are any numbers that will multiply to give me negative 12 and also add to give me negative 1. Negative 4 times positive 3 will give me negative 12. And negative 4 plus 3 will give me negative 1. So that tells me that my two factors here are negative 4 and positive 3. So I need to leave that 3 out the front of the brackets, and then inside 2 sets of brackets I'll get p minus 4 multiplied by p plus 3. And that's now fully factorised. Have a look at number 3 over here first. So I have a y cubed minus 1. Both of those are perfect cubes, so I can use my difference of 2 cubes rule. So opening my first bracket, I take the cubed root of the first term. Cubed root of y cubed is y. And I subtract the cubed root of the second term. The cubed root of 1 is just 1. Then in my second set of brackets, I'm now looking at my first set to figure out what terms go in there. So I square that first term. I get y squared. It's going to be a plus because that's what our rule says. And then I multiply the 1 and the y together to give me simply y. And then I square the last term, which will just give me 1. So fully factorised, I get y minus 1 times y squared plus y plus 1. For number 12, I'll start by For number 12, we don't want to expand these brackets. Instead, we need to recognise that this is a difference of 2 squares. And so I'm going to have 2 sets of brackets. For number 12, we don't want to expand these brackets. We're trying to make it simpler. So we need to recognise that this is a perfect square, and so is this, and there's a minus in the middle, which means I'm working with a difference of 2 squares. So I'm going to need to use a few different levels of brackets here. In the first set of brackets, I need to take the square root of x minus 3 all squared, which gives me x minus 3. And then I add the square root of the second set of brackets. And the square root of x plus 4 all squared is x plus 4. And close those brackets. In my second set of brackets, I'm going to have each of these terms, but I'm going to have a minus in between instead of a plus. So I get x minus 3, close bracket, minus x plus 4. Now this is a case where it is really important to ensure that you include those brackets, because when I come to tidy up here, I'm going to get a couple of things that will change. So I can just take the x minus 3 and the x plus 4 out of brackets, because remember that the term that's outside of this second set of brackets there is a positive 1. So when I expand that out, I just get x plus 4. In my second set of brackets, the x minus 3 can just be written outside of the brackets. Now this is a negative 1 in front of this second expression here. So negative 1 times x gives me a negative x, and negative 1 times positive 4 gives me negative 4. Inside these brackets I now need to tidy up again to collect these like terms. So I've got an x plus x, which gives me 2x. And then I've got a negative 3 plus 4, which gives me positive 1. In the second set of brackets, these x's will cancel. X minus x gives me 0. So I just do negative 3, take away 4, which gives me negative 7. You can leave it like that, or you can write it a little more neatly. Take that negative 7 out the front, because remember multiplication gives the same answer in any order. And then write the brackets. For number 13, again this one looks quite a bit harder than it actually is. Try not to expand unless absolutely necessary. What you need to recognise is that I have a pair of repeated factors there. So when I have repeated factors, I write those factors in my first set of brackets, and then in the second set of brackets you write what's left over. There is another trick to this though. In that second set of brackets there, that is a difference of 2 squares. So I need to further factorise that. So the y plus 5 stays out the front there. And then I need 2 more sets of brackets. I get y plus 4 times y minus 4. And that's question 13 fully factorised.